Hi, so my name is Daniel, and I'm going to talk a little bit about the backend architecture of this Azure RAG application. First, I'm going to go over kind of how the flow of the API requests flow in the backend. So we'll start all the way on the left. So as you can see, we have our users that are communicating with our front-end chatbot application. And that basically manages the front-end requests by the user. So the questions that they ask. So let's say the user asks a question, it goes to the front-end chatbot, which then sends the request out to the orchestrator. And the orchestrator will decide basically what to do next with this query. So the orchestrator can be something like LangChain or prompt flow or semantic kernel. And this will basically decide on what to do next. So as you can see, there's some arrows going up. So there's non-Azure microservices and there's Azure microservices that can basically take the user query and can do a couple of things. It can do semantic catching to help answer questions based off previous user experience. And then there's also, you can go into a vector database to get information based off contextual reasoning. So that's kind of what the orchestrator does. We go back down to the orchestrator. After the orchestrator does what it needs to do and it gets the data and content that it needs, it then makes an API call using the OpenAI SDK, which makes the API call to the app gateway, the API management. And this API management kind of acts as a little gateway. So then we take the API management and it sends in a backend API call to OpenAI. And the OpenAI will then process the tokening time and the generation time, and then return all of that data to that. So a little bit about what it's doing. It's also going to check the latency of the region. If the latency is too high, it's going to use another deployment, basically. So that's kind of why you see two OpenAI deployments on the right. And then basically it just goes back. The API management takes the response, goes back to the orchestrator, and the orchestrator then gives the response to the chatbot front end. So that's kind of a little bit about the architecture. I also want to talk a little bit about semantic caching and what that's actually doing. So semantic caching is basically when the user asks a question, instead of always relying on doing the RAG architecture and using OpenAI to generate the questions to save money, save time, and costs. What we do is we actually use some type of database, NoSQL database, to retrieve answers of questions that may have already been asked or similar questions that have been asked. And when we retrieve them from a database, we use some type of similarity score. And if a user question matches a certain similarity score for a certain question or a cached question answer in the database, then what happens is we basically take take the answer to that question, and we basically just use that. So that kind of allows us not to always rely on generating all the time. It actually allows us to just use already answered questions to answer future questions, which is very cost effective and time effective. And I also want to talk a little bit about how this whole process actually works, where a user will ask a question and then it gets our embeddings and all that. So as I said, the user will communicate with the front end, which generates a user query. The user query is then used to, let's say, do RAG and get relevant context. Well, first, in the backend, what it's doing, it's using a deployed embedding model to embed your sequence into a large vector. And then in the vector database that it's actually communicating to, there's already a large number of vectors that have already been transformed into vectors using that embedding model. And we basically run a similarity search using cosine similarity, and we'll find the top K documents that are most relevant to the question based on semantic meaning. And then it will basically return those documents. And then those documents are then used in the API call for OpenAI. So then it gives OpenAI the context it needs.